How to give your AI agent the ability to execute code safely. In this tutorial, we'll see how we can do this very easily, using LangGraph and a simple MCP server. As always, the first thing we need to do is make sure we have LangChain MCP adapters installed. We will then create our model, set up the MCP server and MCP client, build the agent, and finally test it on a quick example. So for the model, as usual, we grab our secrets from a YAML file and create a simple Sonnet 3.5 model using the chat Bedrock class from LangChain. Of course, you can use anything else, like OpenAI or some local model with LMStudio. Once we have that, we can go and set up our MCP server. So the goal here is to allow our agent to execute some code on a safe, isolated environment that doesn't impact the rest of our machine. For that, we will use the MCP run Python server provided by Pyodide AI, which does exactly what we need. If you don't want the details about how it works, you can skip to this timestamp. So, how does this work? Under the hood, this works using two powerful solutions, called Pyodide and Deno. Deno is a runtime environment, basically like Node.js for running JavaScript. It was created by the same person who created Node, but with more security restrictions and other improvements. For example, your code can't access files or the internet unless you explicitly allow it. Deno is also built to easily run modern things like TypeScript and WebAssembly. Pyodide is a Python distribution compiled into WebAssembly. WebAssembly is basically a fast, low-level bytecode format that can run on the web and in environments like Deno and Node.js. For compiled languages like C or Rust, they can be compiled directly into WebAssembly and then executed. But for interpreted languages like Python, we compile the interpreter itself, in this case CPython, into WebAssembly and use it to run Python code inside Deno, and this is exactly what Pyodide is. By combining these two solutions, we get a safe environment, isolated from the rest of the operating system, in which we can run Python code. Deno provides the secured sandbox that runs WebAssembly, and Pyodide allows us to run Python through WebAssembly. Okay, now that we know how this works under the hood, let's set up the MCP server. We're gonna need a few prerequisites before we can launch the server. First, we need to install UV. For those of you who have never heard of UV, it's simply a very fast package manager for Python. You can think of it as a sort of pip or poetry, but way faster. So to install UV, we simply use pip. Let's run this command in the terminal. Okay, now the second prerequisite will be to install Deno. We do it using curl, and we also install unzip in the same command, in case we need it too. Let's grab this entire command and paste it in the terminal. It shouldn't take very long, and there it is. Here we can say yes, hit enter, and Deno is installed. We can type Deno to test it, and we can see that it works very well. Type Ctrl+C to exit. And we're done with the prerequisites. Now we can finally run the main command to launch our MCP server, using the MCP run Python package. So here we use UVX to execute the MCP run Python package without permanently installing it. We can specify the port on which our server will be reachable, as well as the Python dependencies we want pre-installed, such as NumPy, pandas, and requests. And finally, we specify the transport, which will be streamable HTTP. Let's now grab this entire command and paste it in the terminal. We can see it's installing a few dependencies. It starts by installing the Python packages we specified in the command, and then adds some other dependencies. And there you go. Our MCP server is ready and listening on port 8000. Now that we're done with the server part, we can move on to the MCP client setup. This part is pretty much the same as our last tutorial. We again use the multi-server MCP client from the LangChain MCP adapters package. Inside it, we can point to our MCP server using a config dictionary. We specify the URL, which is our local host on port 8000/MCP, and the transport, which is streamable HTTP. We give it a random name like toolbox, and put it inside this global dictionary, where we can specify as many server configs as we want, which is why it's called multi-server MCP client. Once we set the client, we can check the tools exposed by the server using the getTools function. As a result, we get a list of structured tools, which is already a LangChain object. We can see the name of the tool called Run Python Code, the description, and the full argument schema. Let's take a look at the full argument schema. We can see it's a classic Pydantic schema definition, with properties which are the arguments. We have Python code of type string, which is the code we want to run, and global variables of type dict, which is a set of variables we can set beforehand. And the only required argument is the Python code. With this schema and the description, the LLM has all the information it needs to manipulate this tool. Let's now build a simple AI agent with LangGraph and give it access to this tool. We can do it very quickly with the Create React Agent function from LangGraph pre-built. It takes in the LLM that we created earlier from Bedrock and the tools which we got with the MCP client using getTools. Okay, so now we have our agent. As always, we can visualize it using getGraph and drawMermaid PNG. And we can see it's the basic React framework. And as usual, we have our little run agent function, which streams the internal graph messages with pretty print to help us see what happens inside the graph. Now we can finally test our agent, so we can see the code execution in action. As usual, we test our agent using a very basic sample query. To test its code execution capability, we ask our agent to download a CSV file from this URL using the requests package, then read it and display its first rows using the pandas package. Let's first download this CSV file ourselves to see what it looks like. Okay, so it's a very simple table with 4 columns and 12 rows. Let's now see what the agent does under the hood to handle our query. So as usual, we first have a human message containing our query, followed by an AI message containing the tool call. Here the agent calls the Run Python Code tool from the MCP server with the Python code string argument, which contains the code it wants to run. And this is the code generated by the agent. So first, it imports requests, pandas, and IO, sets the URL variable, and uses requests.get to download the file. It then decodes the contents, puts them in a string IO, and uses pd.read CSV to create a pandas data frame. And finally, it prints the output of df.head, which gives the first 5 rows of the data frame. Now this entire code is fed to the tool through this Python code argument. We then get a tool message from the Run Python Code tool containing the full result of the execution, and as expected, it's the first 5 rows of the table. So this is what the agent sees internally after running the tool. Finally, we get an AI message from the agent explaining the code that was written and the results of the execution. And that's it for today's tutorial. We've seen how you can launch an MCP server for code execution, how you can connect to it with an MCP client, and how you can use it with a LangGraph agent. If you found this useful, don't forget to like and subscribe to the channel, and leave your thoughts in the comment section. Thank you for watching, and see you in the next one.